To understand why this question is so vital, we must first define what a singularity truly is. Everything begins with the fundamental force of gravity, the invisible architect of our vast, expanding cosmic home. Einstein revealed that gravity is not a simple force, but the curvature of space and time itself. Imagine placing a heavy bowling ball onto a taut rubber sheet, causing the surface to curve deeply. A marble placed nearby will naturally roll toward the center, guided by the dip in the fabric. This elegant curvature is how planets orbit their stars, and how stars orbit the centers of galaxies. Now, turn your gaze toward a star at least 20 times more massive than our own bright Sunday. For millions of years, the star maintains a delicate balance against the relentless inward pull of gravity. Deep within its core, nuclear fusion burns brightly, pushing outward with immense energy to sustain the star. But this cosmic dance cannot last forever, as the star eventually exhausts its precious supply of fuel. With the fusion fires extinguished, the outward pressure vanishes, leaving the star defenseless against its own weight. Gravity wins the struggle, and the entire massive structure begins to collapse inward upon its own core. The star becomes smaller, its density rising sharply as the matter is squeezed into a tighter space. It grows hotter, the internal pressure mounting as the atoms are crushed together with increasing, violent force. According to Einstein's equations, this catastrophic collapse never truly finds a point of rest or stability. The process continues, relentless and absolute, as the star shrinks beyond all recognizable physical dimensions or limits. Every atom, every proton, and every neutron is forced into a space smaller than a single point. Perhaps even the fabric of space itself is crumpled, twisted, and squeezed into this infinitely tiny region. This is the theoretical singularity, a point with no size but possessing the mass of a star. It is defined by infinite density, where the laws of physics as we know them simply cease. Infinite gravity pulls at the surrounding space, creating a trap from which not even light can escape. Yet, there remains a fundamental problem that haunts the minds of every modern theoretical physicist today. Nature has never provided us with a single example of an actual, physical infinity in existence. In the realm of science, infinity is often a warning sign, a flashing red light of caution. Think about the act of dividing a number by zero on a standard, everyday handheld calculator. The device does not provide a numerical answer, but instead displays a clear and distinct error message. This happens not because mathematics is fundamentally broken, but because the question lacks any physical sense. Singularities and black holes are strikingly similar, acting as a mathematical error in our description of reality. Whenever Einstein's equations predict infinite density, physicists suspect the equations have reached their absolute limit. Imagine using a simple road map to navigate the complex layout of an entire, sprawling modern country. It works perfectly for highways, but fails when you try to find individual rooms inside a house. The map is not inherently wrong, but it is being used far outside its intended useful scale. General relativity works incredibly well for planets, stars, galaxies, and even the shadows of black holes. Quantum mechanics works perfectly for the tiny world of atoms and the behavior of subatomic particles. But inside the heart of a black hole, both of these great theories must work together harmoniously. Instead, they completely disagree, creating a conflict that leaves us without a clear, unified physical picture. General relativity insists on a singularity, while quantum mechanics refuses to accept the existence of infinities. Somewhere deep inside every black hole, one or both of our greatest theories must be incomplete. Now, let us imagine something truly extraordinary, a possibility that changes our entire view of the cosmos. Suppose nature possesses a hidden safety mechanism, a fundamental rule that simply forbids all infinities from forming. As matter collapses toward the center of a black hole, gravity becomes unimaginably, terrifyingly strong for us. But before infinite density can ever form, quantum effects suddenly rise to become the dominant force. Space itself may resist being compressed any further, acting like a physical barrier against total collapse. Think about the act of squeezing a metal spring, which compresses easily under a light, steady pressure. Push harder, and the spring resists more strongly, eventually reaching a point where it cannot compress further. Some physicists believe that the fabric of space-time behaves in a very similar, resilient, and physical way. Instead of being perfectly smooth, space could be made of unimaginably tiny, discrete, and rigid building blocks. These blocks are millions of billions of times smaller than even the smallest known subatomic particles. At this smallest possible scale, known as the Planck length, space may refuse to shrink any further. Instead of collapsing into an infinity, the matter simply stops, reaching a state of extreme, finite density. The black hole still exists. Its event horizon remains unchanged, and its gravitational pull remains as powerful. But inside, there is no singularity, only an incredibly dense, finite core that defies our current models. If singularities do not exist, we must ask what actually lies at the center of these giants. Scientists have proposed several fascinating possibilities, ranging from quantum stars to exotic vacuum energy regions. Some speculate that black holes could become bridges through space and time, connecting distant parts of reality. Or perhaps every black hole creates a brand new universe, hidden safely beyond its dark, surrounding event horizon. Imagine our own universe existing inside a black hole belonging to another, much larger, parent universe. While these ideas remain speculative, they all share one remarkable feature that sets them apart from singularities. None of these models require the existence of an infinity to explain the heart of the darkness. We are on the verge of a new understanding, one where the universe protects its deepest secrets. As we move beyond the shadow of the singularity, we must reconsider the very nature of existence. If nature truly forbids infinities, then the centers of black holes must be fundamentally different than assumed. The origin of the Big Bang likely operates under laws far more complex than our current models. Instead of a point of infinite collapse, we might find a finite, ultra-dense, and stable quantum core. Perhaps we are witnessing the remnants of a previous cosmic cycle, a process known as a bounce. Theories like string theory suggest that space-time is not a smooth, continuous fabric as once believed. Instead, loop quantum gravity proposes that space-time is composed of discrete, microscopic, and fundamental building blocks. These tiny fragments prevent matter from ever shrinking into the impossible void of a true singularity. This shift in perspective transforms our view of the universe from a singular and fragile beginning. We see it now as an endless, self-correcting process of constant expansion and eternal cosmic rebirth. As we continue to probe these extreme limits of physics, the singularity remains a vital signpost. It guides us toward a unified theory that reconciles the massive scale of gravity with reality. We must bridge the gap between the curvature of space and the delicate, granular quantum world. This pursuit proves that the universe is far more resilient and structured than we ever imagined. The breaking point of our old mathematics is merely the doorway to a deeper, hidden truth. We stand on the precipice of a revolution that will redefine our place in the cosmos. Every calculation that fails at the center of a black hole is a clue left behind. These clues point toward a reality where infinity is replaced by the elegant precision of quanta. The collapse of a star is not an end, but a transition into a new state. Matter finds a way to persist, held together by the fundamental architecture of the quantum foam. We are learning that the universe protects itself from the paradoxes that once haunted our equations. There is a safety mechanism built into the fabric of reality, preventing the formation of infinities. This discovery changes everything we thought we knew about the life cycle of the vast universe. We no longer fear the dark heart of the black hole as a place of destruction. It is a laboratory of nature, testing the limits of what is possible in our reality. The Big Bounce theory offers a vision of a universe that breathes in and out forever. Each expansion is a new beginning, carrying the echoes of the cycle that came before it. The math is difficult, but the beauty of a self-correcting universe is worth the intense effort. We are deciphering the language of the stars, one quantum measurement at a time, searching deeper. The singularity was never a destination, but a sign that our map was simply too small. Now, we expand our horizons to encompass the true, granular nature of the physical world today. The resilience of the cosmos is a testament to the sophistication of the laws governing us. We are finally beginning to see the grand design hidden behind the veil of the unknown. The paradox of the singularity is dissolving, replaced by a theory of profound and lasting unity. We look toward the future with the confidence that the universe is a coherent, logical system. Gravity and quantum mechanics will eventually meet in a single, elegant, and perfectly balanced framework. This is the promise of the new physics, a journey into the heart of all things. We are the observers, finally ready to understand the mechanism that keeps the universe from shattering. The infinite density of the past is fading, replaced by the finite reality of the present. We are moving into an era where the mysteries of the cosmos become clear, defined truths. The universe is not a fragile bubble, but a robust structure capable of infinite, cyclic renewal. We have looked into the abyss and found not a void, but a complex, working machine. The singularity was a ghost in our equations, a phantom born of our own limited understanding. By letting go of the infinite, we gain a much clearer picture of the real world. The granular nature of space is the key to unlocking the secrets of the dark stars. We are witnessing the birth of a new era in our scientific quest for total knowledge. Every star that collapses is a lesson in the durability of the fundamental building blocks. The universe remains, despite the immense pressures, a place of order and predictable physical laws. We continue our work, driven by the desire to know the truth of our own origin. The path forward is illuminated by the very questions that once seemed to lead nowhere. We are closer than ever to the final answer, the theory of everything we seek. The singularity is a relic of the past, a stepping stone to a much greater understanding. We embrace the complexity, knowing that the universe rewards those who dare to look closer. The cycle of rebirth continues, and we are here to witness the unfolding of time. There is no end, only the transformation of energy into new and beautiful cosmic forms. The quantum world is the foundation upon which the entire structure of the universe rests. We stand in awe of the resilience that allows for such a vast, interconnected cosmic dance. The paradox is resolved, the math is balanced, and the universe remains a beautiful mystery. We are part of this grand process, observers and participants in the eternal, cosmic cycle. The journey continues as we unlock the final secrets of the resilient, ever-evolving, infinite universe. Thanks for watching video. If you find this video is engaging, please subscribe to Planetarium.